Good evening, guys. Welcome to the Phoenix Aero Plus workshop. Phoenix Aero Society of Automotive Engineers. So today's session is about Arduino, and this is session 2 of avionics. Today's our speaker is Chinmay Harkawat, our avionics member of Phoenix Aero, and today's session will be hands-on session, so there is no PPT. Just Chinmay will share his screen and instruct you what to do. Just do as he says and follow the session.
Yeah. So
Okay,
thanks, Nate.
Chinmay.
Yeah. So good evening, everyone. As Meg introduced me, my name is Chinmay Harkawat from the Avionics Department of SAE Phoenix Aero. I'll directly start the session now. Okay. If anyone here was in the last session, can you just briefly say what was covered, if you remember? Anyone?
You introduce with the processors and its different parts, how plugs are setups, digital plugs, analog pins, and microcontrollers and all, sir.
And at the last,
Yeah.
you gave some examples on sensors, the IMU,
Yeah.
photoresistors, and all that.
Correct. We did. We did. And I think we mentioned HCSR04 as well. Which I will start. Okay, good. We covered the basic avionic components, microprocessors, their applications, and we got started with a little bit of Arduino and learned basic components like which microprocessor is used, what pins, etc. are there, and those kind of things we did. Okay, most of you remember what was covered. So today we'll start on how to get started on how to program an Arduino. So why do we program stuff? We program stuff to make the machine do what we want it to do. So just so we are clear here, there are no programming prerequisites that are required for this session. If you know some C, C++, Python, that's all right, okay. But the basic knowledge of programming or any prerequisite is not required for this session. We'll be teaching everything from scratch. So first of all, let's understand how we'll be conducting our session today. So I'll start my screen sharing and is it visible? Screen?
Yeah, Chinmay, it's visible.
Okay, so we'll get started with Tinkercad, and I want everyone to type this inside their system and click on join. So this I've already logged in, and this is my class. So we'll be sharing a link. So if have any of you followed the instructions and signed in into Tinkercad? Any of you?
Yes, sir.
Okay, good. So just can I get a yes or no in the chat box as to who has signed in and who has not? If it's a no, just say it. It's not a big deal. Okay. So basically half or more than half have not. So what I'll be doing is I'll be sharing a link with you guys. Okay, and just go on this link. Okay, I shared the link in the chat box. Just go on this link. And I need a volunteer as well who can start sharing their screen after clicking this link. So who would like to volunteer?
Sir, I can.
Okay, cool. Start presenting then. Yeah. So okay, you're already logged in. Cool. So if you can just log out and we can show everyone how you can log in, copy paste the link.
Okay, sir.
Yeah. Log out from this and we can copy paste the link in your browser. So there's this icon on the left top. Yeah, just click on log out. Yeah. So what I want everyone is to take this link in the chat box and type it. Go and copy paste it in your browser. If
Okay.
Jitaksha, I think I'm pronouncing that right. Jitaksha.
Sir is Jitaksh.
Jitaksh. Okay. So Jitaksh, if you can do the same as well, yeah. Everyone, if you're following Jitaksh, please do the same. Copy paste the link in your browser, and you'll see this type of screen. I need a yes or no as to if you have done it or not in the chat box itself. Okay. Okay. And okay, so I think most of you have done it. Now click on this Google thing that you're seeing, right? Other providers, Google, click on that Google. And Jitaksh, what ID have you used for, your institute ID or something else?
Sir, Institute ID.
Okay, cool. So whenever you see, all of you see this screen, you can use any of your accounts. I preferably use your institute ID, but choose either of the account, whatever you're logged into, and click on that. So if you have your institute ID logged in, click on that. Yeah, Dax, if you can click on your institute ID.
Yes.
And yeah, just type in your email and password.
Yes, sure.
And yeah, has everyone done this step? Like typed in your email and password, and then just click on link. So you will be you can also type it. Yeah, sure. Okay, so is everyone seeing the UI that Jitaksh is seeing? If you're facing any difficulties, let us know, screen share, and then we'll sort it out. Done. Okay. Anyone who isn't able to do it, just let us know. Learning the move. Yeah, you are. Done. Anyone who's left, let us know. We'll wait for about 1 to 2 minutes, and maybe then we'll give people. Okay, Subhash Kumar. Yeah, what happened, Subhash? You can unmute yourself and speak up if you can.
Sir, the chat was not share of Jitaksha.
Okay, so what did you like copy the link that we have pasted in the chat box?
I copied the link of yours, the link you provided, sir.
Okay, you have done that, and after that, did you like click on Google, that Google option, find other options Google?
Yes, sir.
Okay, did you sign in using your account, institute ID?
Yes, sir. Institute email ID, sir.
Okay, are you seeing the screen that Jitaksh is probably seeing, or are you not able to see that?
I'm unable to see the
Screen that he's
website.
present.
Yes,
Okay, so what do you see Tinkercad on the right, upright?
sir.
You do?
Sir, it's like showing AutoCAD.
Yeah, it is. Okay, AutoCAD. Okay, we'll just share your screen and then we'll look into this. Others has everyone completed the step?
Yes, sir.
Okay, so so Subhash, you can start presenting if you are not able to. We just want to see what exactly is on your screen.
Sir, shall I stop sharing?
Yeah, you can. We'll ask you to do it again probably, but you can for now. Stop there.
Okay, sir. Okay, sir.
Okay, yeah. Uh, Subhash, you can start sharing. your password and email ID is not matching. So probably your email ID is incorrect.
Subhash, you skip this step for now.
Acha, link
Yes,
account.
sir.
You click the skip button for now. Don't link this account.
Yeah, and yeah, click on continue.
Click on continue.
Yeah, probably click on, welcome Subhash, you're in. If you can keep on presenting, that'd be nice. Yeah, you can close this, click on cross and close this. And on the right hand side, you'll see a bar. Click on your classes. No. The opposite side. Yeah, you click on your classes. Everyone do as Subhash is doing, your classes below lessons. Yeah, your classes. And you'll see this Aero plus avionics workshop. I want everyone to click on that. And also, is everyone following till here? Okay, nice.
So can you tell first, मतलब again, repeat again.
Yeah, sure. So what you have to do is कि आपको जो lessons के नीचे वाला part है ना, your classes का एक दिख रहा होगा, मतलब जहाँ पर आपका ID
Can you
वगैरह
repeat, please,
Yes,
where
sir.
we have to log in?
है. Sir, okay, we have to log in over here. This is the link. You have to log in, and you have faced any problems, let us know. This is the link that you have to start with. Okay, everyone is at this step with which was sir, am I late? Can you explain again? Sure. You just click on this link and follow the steps.
It's the
Yeah. Okay, so everyone are you seeing what Subhash is presenting right now? Okay, good. Now click on Aero Plus hands-on session. Okay, click on this and click on create new design and click on circuit. Okay, this should open in a few minutes. Take some time. Okay, so how many of you are not able to see the screen or have missed some steps? Let us know.
Sir,
Yeah,
when
go ahead.
when I'm trying to join the class,
Uh,
it's showing type the code your teacher shared. Then which code we have to type?
Acha, see, what's happening now is okay. Asim, can you share your screen?
Sir, I'm unable to log in. Please repeat.
Yeah.
Starting से सर बताओ ना कैसे
हाँ,
log in करेंगे.
एक बार Asim just can click on the link and we'll take it up from the top.
Sir, it is showing like this.
Okay. So you'll probably require a code for that. I can share that with you. Just give me a minute. Copy code. I think can you send the link again? Sure. I have the link and the same with me. Okay, see, just click on go back if you can. Join. Yeah, see it's doing. Aero plus avionics workshop. You're already logged in. See. Yeah, can you send the link again? Sure, this is the link. And click on Aero plus hands-on session. Okay.
Sir,
We
may I
have to
stop
join
my
using
screen share?
institute method.
Yeah, you can. I think it would be preferable if you join from your laptop or PC, right? Be better. because it will get a better experience.
So, sorry to interrupt. So, for those who still cannot log in, I'll share my screen and show you how to do it once again.
Yes, sir.
So,
Please, sir.
is it visible?
Yes, sir.
Yeah.
Okay. So, after you click that, you'll find this this thing on your window. So then you have to click on this Google, and okay, I think
It logged in automatically. What you
hmm,
basically have to do is type in your email ID and password, and it will log you in automatically.
exactly.
Yeah. Gaurav, I think you are facing problems. Did you understand the process? Okay.
Sir, after clicking on your glasses, it is showing to me that collect information, something like that.
Okay. Can you share your screen if possible?
Yes, sir.
Uh, you can log in using your laptop. That would be better. Will that will be much better rather than going with a PC. Sorry, phone. Mm, okay, Aman, did you get that? Log in using your PC, and you will probably not face this problem. Acha, yeah, you probably not face this problem. Okay, we will start the session now. I feel everyone, most of you have done this now. I'll start sharing my screen, and what I want you guys to do is follow along with me. Okay, follow along with me. I'll be creating an activity already created, and okay, and I'll be creating a new design. You can view my design anytime, and what you guys have to do is click on circuits. You see a create new design option here as well, and you click on this and click on circuit. Okay, and you will be able to make designs as well. So this is the Arduino Tinkercad interface. We'll type Arduino here and put the Arduino over here. And the first mission that we have for this session is to make an LED blink. Okay, that's the first mission that we have, and we put in Arduino over here. We'll put in LED as well. Okay, so how you put this? You set in Arduino, search Arduino, and just click and drag it over here. Select LED, and you just click and you just drag it over here. That is all that you have to do. Okay, so you have this. Now connect this to the ground. Connect this to 6 volts. Okay, do this first, and then we'll move on to coding directly. Okay. So I feel everyone is following along with me. Now let's just have a look at the code. To start programming this Arduino, what you need to do is click on this code, click on text, and just erase everything. Okay, we'll write everything from the start. Okay, just let me have a look at what, what is everyone doing. Yeah, so a lot of lot of you are in. And okay, most of you seem to have connected. Okay. If you have extra components, you can select and delete, and it should go away. Okay. So we'll start programming. The first command that we'll type basically is void setup. Okay. Let's just close this block and let's go into depth as to what this void setup exactly is. So void is a return type of a function. Now, what is return type? What is the function? I'll just explain. Okay. So you remember those y equal to f of x equal to sin x functions in sets and relations in +1, +2. So x was basically your input, y was your output, and fx was your function, right? And suppose we put x equals 45 degrees, right? And what do we get y as? 45.
Chinmay,
Yeah.
your
Screen.
only Gmail screen is visible.
1 second, I'll just share the entire screen. Okay, it should be visible now.
Yes, Chinmay.
Yeah. So y equal to f of x, you remember, I guess, sets and relations. Y equal to f of x equal to sin x. X was your input, y was your output, and f of x was a function. So when x was 45 degree, what was y? Y was sine 45, which is 1 by root 2, which is 0.707. Now this is a 0.707 is a decimal value. And in programming, this decimal value is called float. Similarly, if you have another function, y equal to tan of x equal to 45 degree, y is equal to 1. Now what is this 1? 1 is an integer. In programming, we call this integer as int. Okay. So let's just get back to our circuit and see what this void is. Now this setup is a function. You will type your commands over here and you will put your x's over here. And this void is basically your return type. Return type can be double, it can be integer, it can be anything. For now, what we have set it as, कुछ return नहीं कर रहा अभी हमारा function. It will just take in commands and that's it. So why setup only? Why not name this as something else? क्योंकि यार Arduino का syntax है, this is the syntax for Arduino that we use, and this is like preset. There are some predetermined rules in programming that you have to follow. Okay, so now we have this block, and we type pin mode. We have connected the LED to 6. So 6, output. Okay. So just everyone type this code into your console as well, and we'll see what we can do. So pin mode 6, output. For now, just hold on to this code, and we'll discuss in detail what we can do with it. Now the second block of statements, the second function that we have to write is void loop. Now, what does everyone understand by void loop? What does everyone understand by loop? Can anyone type in the chat box? You can feel to unmute as well. What do you understand?
Continuous function means continuously it will run.
Okay. Anyone wants to add something? Exactly. Something which repeats. You know, there can be a condition which is satisfied, a condition which is true, if it's false, it can be there, but it at a very basic level, it is something I'll repeat. So pin mode, digital write 6, high. Okay, digital write 6, high. The next command, digital write 6, low. Okay, now what are these 2-3 commands that we have written over here? First, let's keep everything aside and let's see if this code is running or not. That's the first high that any programmer gets, is uska code bina bugs ke run ho gaya. So let's just try this out. Okay, so the LED is switched on, everything is working fine, and it seems that we are getting closer to our objective. So let's stop this and start discussing this. What is pin mode? Pin mode is setting the pin. We have defined the pin number 6. It can be two things. It can either take an input or it can either give output. Okay, we'll elaborate on this in just a while. But pin mode, we are defining the pin number 6 as either input or either output. It can be either here, it can be either input or output at a very basic level. Now, digital write. What does digital write do is it is defining this pin number 6 as high. Now, if we talk about this very basically, this ground is 0 volt, and when this pin number 6 becomes high, the current, that the voltage that is there in this pin is 5 volt, and when it becomes low, it is 0 volt. So when this command is executed as pin number 6 is high, this becomes 5 volts, this is 0, this is 5, there is a potential difference. And if there is a potential difference, current will flow through the circuit. So 0, 5, there is a potential difference, current flows through the circuit, and this is how the LED gets current. Now, digital write 6, low. Low, 0, low means 0 volts. There is little to no potential difference, and current stops flowing. Okay, now let's just
repeat once it.
You want me to repeat this digital write thing?
Yes, so high and low. I
Yeah.
get confused a little bit.
Okay, sir. So, digital write pin number 6. What we are doing is we are commanding the pin number 6 to become high, and that is we are commanding this to become 5 volts. Okay, so when this command is executed, the pin number 6 becomes 5 volts. How is it becoming? That's a later point of discussion. But what's happening when we execute this line? Pin number 6 becomes high, 5 volts. Digital write 6, low. Low means 0 volts. 0, ground is 0. Low is 0. There is no potential difference, and current is not flowing. Hence, the LED will not glow when this command is executed. Okay. Now, let us just make a very simple change in this code. Let's just write input here. Okay, and now I'll run this code. And the simulation is happening in front of you. Now, what do you think is happening? What is the difference between output when pin mode was in output mode and when pin mode is in input mode? Can someone tell me? You can write it in the chat box. This is the basic simulation that is running. And what is the difference between pin mode output and pin mode? The visual difference that you see.
In output, it was saying that when the 6 becomes high, then you have to glow.
But that is happening here as well. This line of code is executed. We are going into this, and let's just stop the simulation. Notice the color. This is dark red. Okay, this is very dark red. I start the simulation, and it's glowing. It is glowing. Okay. Now let me stop this. Let me put in output again and start the simulation again. This is dark red. and this is glowing. So both of the times it is glowing, but what is the difference, that is visual difference, that you see during output and input?
I guess low light.
Exactly. The intensity, that is the LED with which it is glowing, is low. Now let me go into a little bit depth as to why this is happening. So you see this pin number 6. When we give the command, okay, pin number 6 become input. What happens is this pin becomes a high impedance. It goes into a high impedance state. Now, does anyone know what impedance is?
Analogous to the resistance.
Yeah, it's similar, but not exactly the same. Impedance is basically the opposition that is given to flowing current. Okay, that is impedance. So when this becomes input, actually this was a very good point, and keep this in mind that it is similar to resistance. We'll take this later as well. So pin mode becomes input, and the impedance becomes high. Now I change this to stop this simulation, change this to output. I start the simulation again. This is growing, initializing, yeah, and this is growing very brightly. So the thing is that when we put in input here, the resistance that was there in this circuit, the resistance that this circuit was having was around, I think, 100 ohms, 100 mega ohms. And when we put this as output, the current that is flowing, note the current that is flowing is around 40 milliamps. So there is a very, very large difference. If you ever get the chance, take an ammeter and measure the current that is flowing through this. You'll find you'll be surprised. You see this exact same result that we're getting here in your experiment. Okay. Now we stop the simulation and we take in input and start it again. Okay, now you have seen both input and output as well. But remember what was our mission? Can anyone tell me what was our mission? The first goal that we started with in our when we started this session. What was the goal that we had in mind? And what we are at right now? Can someone specify? Okay, everyone has forgotten. Exactly, we wanted to blink the LED. But right now, is the LED blinking? Let me change this to output and start the simulation again. Do you see the LED blinking? It's just on. It's not blinking at all. So
Yes,
what
sir.
do we? Yeah. Okay. So what do we need to do? Is we need to go into compiler mode. Okay, and execute each and every line in our mind step by step. So void setup. Okay, cool. We have defined a setup function which has return type void. It is returning nothing. Pin mode 6 output. We have defined the pin number 6 as output. Void loop. This block of statement should repeat again and again and again. And digital write 6 comma high. Now 6 high 5 volts current. 6 low 0 volt no current. Okay. So what is happening is we are here 5 volts and this is 0 volt. 5 volts 0 volt. 5 volts 0 volt. 5 volts 0 volt. Again and again and again. It's just going, I don't know, but it's just going from high to low to high to low to high to low. So what do you think? What do you think we need to do to make this thing, okay? तो अब जाके ब्लिंक कर, खाली हाई लो मत जा. हाई लो करेगा तो तेरा ब्लिंक का एक पार्ट आएगा. But what do we need to do? What do you need to introduce into this code so that we have a constant state? कि थोड़ी देर हाई में गया, फिर थोड़ी देर लो में रहा, फिर थोड़ी देर हाई में रहा, थोड़ी देर लो में रहा. What do you think should be introduced?
Condition.
प्रोग्राम को सर लूप में कंटिन्यू करना होगा.
सर टाइमिंग डालनी पड़ेगी.
If else condition.
If else you will introduce. Okay. Okay, let's keep that aside for now. Some more simpler. I'm looking for something more simple.
सर टाइम डिले करेंगे, मतलब थोड़ा टाइम का.
चलो ठीक है. अगर
सर
टाइम एक बार
इंटेंसिटी कम हो फिर वापस मैक्स आउटपुट दे.
कैन यू रिपीट, मतलब बोलो वापस, खुल के बोला यार.
सर इंटेंसिटी को पहले थोड़ा नीचे हो फिर वापस से मैक्स आउट इंटेंसिटी.
वो तो अभी भी हो रही है यार, मतलब 5 volts. If this was 5 volts and this becomes 0
Can we
volts.
change from output to input in just seconds?
This output is a command specific for pin mode. It's not for digital, right? This is a syntax. Okay.
If you use the input output, so it will generate a blinking.
No, not really. Let's
सर
see.
अगर
Okay.
हम टाइम ऐड कर देंगे,
हाँ,
हम टाइम
तो
ऐड करेंगे.
टाइम ऐड करेंगे, तो टाइम ऐड करके देखते हैं यार. तो let me stop this simulation. And there's a specific command in Arduino called delay. Okay, so delay. Okay, I have added time as you had asked. Okay, मैंने time add कर दिया है and I am starting the simulation again. Not blinking. What happened? What went wrong?
सर हमें उसके बाद भी जो ब्लिंक कम हो जाएगा उसके बाद भी एक बार डिले डालना पड़ेगा ना.
आना पड़ेगा तो सही. So what is happening? See, high pin digital write high. We have this has 5 volts and then we have introduced a delay. Delay is some time, then it's going to low and again directly is going to high. It's not waiting. We need to add a delay here as well. ताकि हमारा सिग्नल कैसे बने? डिजिटल राइट हाई, डिले इतना है, देन लो. थोड़ी देर इधर रखें, हाई देन लो, हाई देन लो, वापस लो है फिर वापस हाई हो रहा है. So we need to introduce a delay here as well. Enough. Let's try to run this. Congratulations. Okay, you have made your LED blinking circuit and it seems to be working fine. Okay, so how many of you have reached this stage? Like, I just want a count as to how many of you have. Okay, Keshav, go ahead. You can unmute. Okay, you have reached this stage. Okay, yeah. Okay, you can just type in the chat box. If you have some doubt, raise your hand.
Sir, I also tried it.
But
it's not working. Sir, I write instead of 1000, I write 10. The code is not working also.
Acha, very nice. So let's just take this 10. And I forgot to ask this actually, but just remove this and go ahead with this. Yeah, either be high low, it was becoming high, it was becoming low. But why isn't the LED blinking? Or is it blinking? This is the main question. Is the LED blinking or is it not?
Sir, it is blinking, but it is not visible by our naked eyes.
Yes, that is true. It is blinking, but it's blinking so fast that we can't see it. Same for goes for delay 10. If stop the simulation.
So the time is in seconds?
The time is in milliseconds. Okay, so I start the simulation again. It's blinking, but it's not visible. Let's take 100. Start. It's blinking very fast. Let's stop this. 650. Not visible. 75. Still visible. If you do it in an actual Arduino circuit, I think it comes down to 7550. Yeah, this is very accurate actually. Comes down to 7550 milliseconds. So I'll stop the simulation for now. And everyone, I hope you have reached the stage. If you are having anything, you can raise your hand. Otherwise, we'll move forward. Okay, so I'm assuming that everyone has reached the stage. And now we move on to the next part. I start the simulation again. And I notice a warning that is showing over here. That current to the LED is this much, and the recommended maximum, I hope this is visible, I'll read it anyway. Current through the LED is 25.5 milliamperes, while the recommended maximum is 20.0 milliamperes. The usable lifetime of the LED may be reduced. Okay, so what this means is the current that is flowing through this circuit is higher than what is required. Not required is not the right word, but what is advisable. So the battery, the LED kharab ho jati, the LED gets ruined because a lot of high current flows through it. So now I want solutions. I just want solutions that how can we reduce the amount of current flowing through the circuit. Yeah, so I hope everyone got the problem statement. We need to reduce the amount of current that is flowing through this circuit. How can we do that?
By adding resistance.
Resistance.
Exactly. Resistance add कर दो यार, अपने आप ही कम हो जाएगा. So let's just add a resistance. Delete this. Connect this to again 6. And yeah, one more thing, you can change the color of your wires. Just click on this wire, click on black. Ground is usually black, and 5 volts or the higher voltage of the power source is usually red. Okay, this is a convention that is followed, and it'd be nice if you follow this as well, because some conventions, some rules are meant to be followed. So this ground is usually black and power or 5 volts is red. Okay, so let's start the simulation again. It's blinking. Okay, it's not blinking, but it's on. Now what can we do to increase the brightness of this LED?
Lower the resistance.
Correct. Exactly. Just lower the resistance, you'll automatically increase the brightness. Let me just introduce another LED over here. Green. And you can double click on this resistance. And yeah, what I'll do is I'll start the simulation and you're already seeing the difference. This is high intensity, this is low intensity. This is still blinking, mind you. I'll show it again. This is dark red, dark red. This is on, and this is also blinking. I'll start changing the resistance. From kilovolts, I'll do it to ohms. You can see the difference. I'll give this 5. I'll give this 10. 15. It's dimming. 20. 25. 50. 100. 500. It's almost out now. Okay, the main current is going over here, but since the resistance is too high, the current doesn't go too much over here, so it's very low. So 100 seems 50 seems like a good number. Not 50, 25 seems like a good number. Also notice that when I'm changing these resistances, the color coding is also changing. I think you've studied this in plus 1 plus 2, that resistors have some color coding according to which the resistance are decided. I have a kit here as well. I'm not sure how much you will be able to see it, but this is basically a resistance. The resistor. Okay. Let me see if it's visible or not. Yeah, this is basically a resistance. Might not be. It's not very clearly visible. Either way, this was a resistance. I wish the next was better. Either way, I'll stop the simulation and let's focus on one point now. Okay, changing this resistance again and again was very tedious. Typing 15, 10, 20, 100, 150, very tedious. मजा नहीं आया यार कुछ करते इंजीनियरिंग जैसा जिसमें यार थोड़ा लगे कि यार जुगाड़ लगा है कुछ ऑटोमेट किया है कुछ अच्छा लगा. So let's stop this and introduce another component, which is a potentiometer. Okay, you can rotate components using this. Okay, you can rotate components using this. You can use the R key as well. R key on your keyboard to rotate components. Okay, now this potentiometer, let's zoom in a bit and see what these three terminals basically are. This is terminal 2, terminal 1, and wiper. Wiper is your signal. This basically gives you the signal. I'll connect this to A0 for now. Let's see what happens. Terminal 2. Terminal 2 is connected to 5 volts. Okay. Terminal 2 is connected to 5 volts. And terminal 1 is connected to ground. Also, yeah, I missed one thing. How did I identify that I wanted to connect this to 0 volts and this to 5 volts or the pin? How did I identify that? मैं तो उल्टा भी कर सकता था. I basically delete this, I delete this, I connect this to ground, I connect this to this. Let's try and simulate this. This is not blinking. So how did I know that I have to connect this with this? This with
LED
this.
works on
Go ahead.
फॉरवर्ड बायस में होता है.
फॉरवर्ड बायस तो ठीक है, बट आप अभी यार आपके पास लैब में एलईडी है और आप उसमें अंदर खोल के थोड़े चेक करोगे यार फॉरवर्ड बायस है रिवर्स बायस है. आई एम टॉकिंग अबाउट प्रैक्टिकल.
एनोड टर्मिनल मुड़ा हुआ होता है. एनोड टर्मिनल मुड़ा हुआ होता
है. एनोड आपका टर्मिनल होता है ना, वो आपका लंबा होता है. ठीक है. आई हैव एन एलईडी ओवर हियर. ये भी दिखेगी कि पता नहीं, बट सी दिस वायर इज बेसिकली मच इज लेंथी, मतलब ज्यादा बड़ा है देन इट कॉरेस्पॉन्डिंग. सो जो बड़ा वायर होता है ना, यू हैव टू कनेक्ट दैट टू द पॉजिटिव टर्मिनल जो आपका हायर voltage is there, and the shorter wire should be connected to the 0 volt. Okay, moving ahead. Forward wire, reverse wire is also correct, but it's little bit in depth. उतना भी लेबोरेटरी में हमको जल्दी जल्दी काम करना होता है. That's why we have to see कि अच्छा LED का ये पॉजिटिव टर्मिनल और नेगेटिव टर्मिनल से कनेक्ट करना है. Now we'll introduce one more thing and you'll see the importance of that as well. Okay, so we have connected this to 5 volts. So let's rename this as red. We have connected this to the ground. Let's name this as black. And now our circuit seems set. Okay, circuit to set lag raha hai. Let's go on, come into coding. So pin mode. Now what pin have we used here? This is A0. Okay, let's write A0 over here and input. Okay. What I have done here is I want this potentiometer to give me things, give me readings or voltage or signals basically as input in this pin. Okay, so I have named this as input. Void loop. Let me delete this. Okay. Now someone mentioned if statement, so we'll be going a little bit into that. Analog read A0. Let me start this. Okay, so what is this hocus pocus? Analog read is great. What is all this? Pin mode we have already discussed. Okay, analog read. This is a command to read analog signal. Okay, Ratnadeep sir did go into detail in the last session. So if you didn't watch it, go ahead watch it. If you did, you should probably get some idea as to what this is. There are still a lot of things that can be explored in this, and if I'll encourage you to do that, to explore this. And if you have any doubts, come on Discord. We can discuss that then. Okay. So analog read is greater than 3.3. मतलब अगर यहाँ का potential 3.3 से ज़्यादा आ रहा है, तो execute this statement. Otherwise, execute this. If or else is simple English. If this condition is happening, execute this statement. Else, execute this statement. That is it. That is all that you have to do. So we have successfully written the commands. Let's just start the simulation. Start. Okay. Now, this is blinking. Now let's just find that 3.3 volts. Okay. See. I'll have to probably decrease this resistance with me. Or it will properly visible. Okay. This is our sweet spot. This is 3.3. When the potential is greater than 3.3, the LED should blink. This is greater than 3.3 and this is less than 3.3. So did everyone understand how potentiometer works? If not, we have an example ready for that as well. If you didn't understand it, let us know. And I'm hoping everyone knows potentiometer. If not, let us know and we'll clear that as well. Very basically, yeah. So what happens in a potentiometer is you have 0 volts, this is the ground, and 5 volts. So you have two terminals, they're connected over here, 5 volts, 0 volts, and this knob is basically for variable resistance. So if resistance varies, voltage will vary, and if voltage is vary, our signal will change. Okay. So let's just start the simulation again and have a look. Okay, LED. Yeah. So right now, our voltage is less than 3.3. Okay. So what is executing? This line of code is executing. We increase the voltage and the LED lights up. So as soon as the voltage is increased, it understands that I have to execute this command, and accordingly the LEDs light up. Is it clear now? Okay, it seems it is clear. Okay. Now, so what we have done now is we have introduced LED blinking. We have seen that using resistances, we can increase or decrease the brightness. We have increased the potentiometer because it was just a very engineering thing to do, and we wanted to get out of this, typing this manually again and again. Wanted to get out of this, so we introduced a potentiometer. Now, what say that we wanted to connect 20 components? We wanted to connect not 20, let's say 50 LEDs on a single Arduino. Do you think that would be feasible? 50 is also less. Let's say 100 LEDs you wanted to connect to an Arduino. Would that be feasible with the amount of pins that you have? So I think Ratnadeep asked the question in the previous session as well. So that was meant for this session as well. So if you did think upon it, the answer should come. If you didn't, then कोई बात नहीं, अभी सोचो. नहीं है ना, basically नहीं है possible. 100 LEDs you can't connect. What we do, we introduce a breadboard. Breadboard is a godsend thing. You'll understand the importance as you get more into circuit. But what we'll be doing now is trying to connect multiple LEDs to one single Arduino. We have done that for 2. Let's try to do that for more. So let's connect this 5 volts. Let's take this over here. This is black. Let's take this 5 volts. Connect this to the positive terminal. Okay. And let us take this ground thing. Ground. Where is ground? Yeah. Ground. Yes. Okay. Now let us connect an LED. We don't know where yet, but let's try and connect this over here. And just start the simulation. Okay. Yeah. And let's just start the simulation. Okay. We connected the wire here, but the LED is blinking over here. Why is that? What's happening that led to this phenomenon? We connected the wire over here, and the LED is blinking over here. What happened? Okay, no answers. So I'm assuming, so audio need more time. Write in the chat box, we need more time. Yeah. Okay, so see what's happening here is when we connect this red, this red is basically 5 volts, this black is 0 volt. When we connect this to positive and negative, this entire line becomes 5 volts. This entire line becomes 0 volt. Let me connect another LED. Let me rotate this, and let me connect it to this. Okay, let me start the simulation. One more, or did you understand? Yes, one more then. Sorry, I didn't get you. Okay, and let me start the simulation. This entire line becomes 5 volts and 0 volts. Let me stop the simulation, delete this, and delete this. Now let us place an LED over here. Okay. Let us place an LED like and let us connect this. Remember, this is the entire thing is 5 volts. Let's connect this 5. Connect this. This entire thing is 0. This is 0. Let's do the same thing over here as well. This is 5 volts. This is 0. And let's start the simulation. Okay. So I want you guys to think that why did this blink, why is this blinking, and why is this turned on, and why this isn't. What do you guys think? What can be the answer?
That was not blinking because 5 volt and 3 volt are connected. 5 volt and grounding was done simultaneously. The same current follows in the that line, sir.
Close, close. I want you to be a bit more specific. You're close.
Sir, in this, the current flows in line, means it's in lateral line, not it's in horizontal, not on vertical basis.
So if I say that I connect an LED, one more LED like this over here, okay? So should this blink or should this not blink?
It will not blink.
Why? You're all of you. You're on the right track, but I want you to be a bit more, specific.
Sir, it is connected in reverse biased or something else.
Not that complicated. It's a very simple answer.
Sir, all the points on 10 will be having same potential.
Okay, yes, this is what I was looking for. All the points on 10 will have same potential. As we had it here, like everything on this, when I connected this to 5, everything became 5. When I connected this to 0, everything became 0. Similarly, it follows here as well. These, when I connect these in horizontally, become part, they are not connected to, they become part of a different circuit. They are not connected to each other. And when I place them in the horizontal direction, they are in the same circuit, in the sense that if I connect another LED over here, yeah, if I connect this an LED in the same line, it will blink because the same voltage has been applied to the for this 5 volt has been applied over here. So this line got this 5 volts from here, and this line, this horizontal line, got its 5 volts from here. So in horizontal line, the voltage is shared, whereas in the vertical lines, the voltage is not connected. If I add another LED over here, it will not blink because the voltages are not connected.